Hello student, welcome back. I am Dr. Keshao Mahale and we are going to discuss Sommelet rearrangement in this lecture. Now, what is Sommelet rearrangement? Firstly, we have to keep in mind Sommelet rearrangement is found in quaternary ammonium halide salt. The quaternary ammonium halide salt, which having one group is a benzyl and another groups are the alkyl groups or the methyl groups or the both. But there should be one condition we have to keep in our mind. With the benzyl group, there should be there should be alkyl group which having at least one alpha hydrogen atom. Only and only then the Sommelet rearrangement is here is a form. So Sommelet rearrangement will be found here. So, tertiary ammonium halide, which having one group is a benzyl and another group is a alkyl group or methyl group, which having at least one alpha hydrogen atom, and react with the strong base such as the sodamide, then there is a rearrangement. This compound, this quaternary ammonium salt will undergo the rearrangement and give us the tertiary amide. So, let us write here the conversion. Conversion is a quaternary ammonium salt. Conversion is quaternary ammonium salt, ammonium halide or ammonium salt to the tertiary amide. When you use here the strong base. Let us take here the mechanism and the example simultaneously. See here the example. This is the first example. So here is, see, this is the C6H5CH2. This is nitrogen here. This is the methyl group here. This is another methyl group here. This is third methyl group here. And this nitrogen having no positive charge, and here is the iodine which having the negative charge. When such a type of compound, we react with the strong base sodium amide in liquid ammonia. At that time, this sodamide, this is NH2 having negative charge, will be takes this hydrogen. For our simplification, we draw this hydrogen here, and this NH2 minus can pick up this hydrogen, and there will be formation of benzylic carbanion, which is the stable carbanion. See, this is the benzylic carbanion, CH minus. This is the benzylic carbanion. Now, this is the nitrogen. This is CH3 here. This is CH3 here, and this is CH3 here, and this having no positive charge here. Now, this benzylic carbanion can takes the hydrogen from this CH3. This benzylic carbanion can takes hydrogen from this CH3, and there will be formation of another carbanion, and this another carbanion can be write in this way. This is double bond, this is double bond. Now this is here the CH2, this is here the CH2, and see, this is the nitrogen which having 3 alkyl group. This is CH3, this is the CH2 now, and this CH2 now having negative charge, and this nitrogen now having positive charge. Now see, this CH2 carbanion will attach to the ortho position of phenyl. This bond will be shift here, this bond will be shift here, this bond will be shift here, and this carbon nitrogen bond will get break. We got here the neutralized nitrogen, or the positive charge getting neutralized, and this is the this is the another structure which will form here. See, this is the phenyl ring, This is the finished link. Here is the CH2. Here is the CH2 attached to this, and next to the CH2 there is the nitrogen. This is the CH3 here, and this is the CH3 here, and here is double bond, here is double bond, and this is CH2 double bond. This is the CH2 double bond. Now again, see, this is the hydrogen here, which can be picked up by NH2 minus, and after that there is the aromatization, and from ammonia it can take place the hydrogen, and last product is the tertiary amine. This is the CH3 here, and this is the CH2 here, CH3, and this is the CH3. This is the tertiary amine. So in this way, quaternary ammonium halide will react with the strong base. It will be given the tertiary amine. Let us discuss here the another example. See, the another example is given here. Another example is given here. See, this is the CH2 here, this is the nitrogen, this is the CH3, this is CH3, and this is CH3. And we can write here this is bromine charge, this nitrogen having positive charge. The reagents are given here. This is the NaNH2. Second reagent is the CH3I, which is given in excess quantity, and then after, and here is another is CH3I is given in excess, and this is also given in excess form. This is also given in excess form. At that time, what happened? We know that this example is like the earlier example. So I directly write here the product. So by the Sommelet rearrangement, we can make here this is the CH3 here, and this is the CH2, and this is CH2. This is nitrogen here. This is nitrogen here, and this nitrogen having CH3 here, and this is the CH3. This is the product of Sommelet rearrangement. But what is about this excess methyl iodide? We know that when tertiary amine react with methyl iodide, when tertiary amine react with the alkyl halide, tertiary amine react with alkyl halide, then there will be formation of again quaternary amine, and quaternary amine will be like this. This is CH3, this is CH3 here, and this is CH2 here, and this is nitrogen, this is CH3, and this is again CH3 here, and this is the CH3 here. Now there is again formation of quaternary amine, and by using the excess sodamide, there will be again formation of Sommelet rearrangement, and after Sommelet rearrangement, and we got here the new product will be like this. See, this is the CH3. I will directly write here the example. This is again CH3, and here is the CH2 nitrogen, CH3. Here is the CH3. So by by using here excess CH3I and excess NaNH2, we can got here the product which will be like this. So this is the CH3, this is the CH3, this is the CH3, this is the CH3 here, this is the CH3 here, this is CH2, this is nitrogen which having, this is one CH3, this is another CH3. So this product will be formed. This is the CH2. This product will be formed here. This is the tertiary amine. So when we use here the excess NaN2 and excess CH3I, so Sommelet rearrangement followed by the Hofmann alkylation, and again Sommelet rearrangement, and again Hofmann alkylation, and finally we got this multi-substituted product. So friend, this is the Sommelet rearrangement which give us the quaternary ammonium salt into the tertiary amines when react with the strong base.